Okay, so we'll be very fast in going through some questions that might be similar to what you'll be lighting on that day. That's Friday, I'm told. So we'll go through some questions and you just need to pay attention. So remember, it's a revision. So by it being a revision, then we'll be very fast. So we'll be very fast. So you need to be also attentive. All right. So without even wasting our time, shall we start? Okay, so this is the first question we have here. All right, so the question says, let me just change the pen there. Okay, so the question says, light 2.517 bar in the form of A over B, where B is not equal to 0. A and B are just members of integer. So we are going to express in the form of A over B. So what do we do? So we say, so we'll let n number be equal to this thing here. I mean n variable. So I'll say let x, okay. So you explain to say let x be equal to the same thing you have there. All right, 517 bar like that. Okay, so the first thing that you need to do here is, let me just light it properly. The first thing that you need to do here is you bring the same thing the way it is there. All right, then we have 517 bar. Okay, so you make sure that this independent, the one which is not in the bar, comes to this side. So what do we do? Then you multiply times what? Times 10, so that the point can come there. So this will be 10x, all right? You multiply throughout everything by 10. So that will be 25, all right? Then 0.17. So by you making this, we'll call this as equation 1, okay? Because you have at least shifted the independent number to your left, then this is equation 1. So now the remaining thing is just to take this one to the other side as well, so that we can have something on the left which is from the bar. So then we multiply times what? Times you multiply this equation times 10 times 100, so that this point can come there. Remember, they were a lot, 1717, so it will just come here as a point. So when you multiply times 100 there, here it will be 1000. So here it will be 1000 x then is equal to 25, all right, 17, all right, point, again 17 bar, like that. So this will be our equation 2. So you subtract now 1 from 2, so that this and this will be 0. So now we are subtracting 1, all right, 1 from 2, all right. So when you subtract that one, it will give you what? So you say 1000 x is equal to 2517.17 bar, then minus, we have 10x there, right? Then is equal to what? 2517 bar. Okay, so subtracting this will give us what? This will be 990. 1000 minus 10, that will be 990. Okay, x is equal to, when you subtract this, will give you 0, right? Then 5 into that, that will be what? That will be 2, all right? So that into that, that will be 9, then 2, 4, all right? So 2, 4, 9. Okay, so then you can divide throughout by 990, all right? 990, okay? So say our x now is equal to 24, okay, 92 over 990. So this is now in the form of A over B. We can see, and the same B is not equal to 0, right? This B here is a number, so it's not equal to 0. So that's how you solve this such type of questions. All right. So now we'll go to the other one as well, where we are told to actually show something. Okay. So it's a complex. Okay. So we're having a complex number there. Okay, how do we do this one then? Okay, so the best way you can approach this question is by saying, we need to have something here, all right? So we are given z as, z is equal to 3, all right, plus I, which is the imaginary number, all right, over 1 minus the same I, imaginary number. Okay, then what we are going to do here, we are told this is our Z, by the way. Then we are just told to find Z minus 1 over Z. So let me just make Z to be a real number so that I can at least do something even if I'm writing this fraction form. Okay, so the complex form, it will be like that. So let me just now maintain this one. So I'll say Z. I'm going to perform some calculation on Z so that I can make it to be real. All right, or just to be in the form of A over B alone Z. All right, so we have 1 minus the same imaginary number, which is just 1 imaginary. So like that. So how do you achieve by bringing it in this form? So you multiply now this one by its conjugate, all right? So its conjugate of this one, what is you just what rationalize the denominator so that you can have this form. By rationalizing the denominator, it means you are canceling something which is down, then so that you can just have the numerator the proper form like that. So what you're going to do here is we multiply this one by its conjugate. So the conjugate of 1 minus imaginary, which is the complex, it will be 1 minus plus the same imaginary there. Then the same thing, you do it on top. All right. So there's nothing we have changed here. This is just 1, right? So you multiply this, and this is difference of 2 square here, down here, right? So there, what to multiply is just on top. Down here is the difference of 2 square. Okay, so we are multiplying throughout everything, by the way, remember. So when we multiply this one, 3 times 1, that would be just 3. Then 3 times I, that would be 3i. Then 1 times I, that is just 1i. Then again 1 times I times I, that would be just I times I times I, or I squared is equals to -1. So here we'll put just -1. All right. Then over, this is different of 2 squares. So we'll just put 1 squared minus again I squared. Okay, so this will give me this 3. It will be 3 minus that will be just 2, right? So this will give me 2. 3 minus 1, that's 2. Then 3i plus 3i, that is 4i. Okay, then over here it's 1. Then I squared is negative, so this will be plus, that will be plus 1 again, because it will give us negative there inside, then which will add, then give us plus. So that will be 2 plus 4i, all right, over 2. So this can be written as 2 into 2, that will be 1, right? So you remove the 1. So you divide there, that will be 1, then plus, that will be just 2i. Okay, so this is now our Z. Have you seen the way I've just conjugated Z? So Z is now in this form. So now it will be very easy for me. It will be very easy for me to actually simplify it according to the way I've been asked. So I'll say my question is Z, all right, minus 1 over Z. So I'll just bring the Z and also Z down there. You get? So I can say, if I want again, I can still do something with Z, but let me just remain it like this. So I'll say now I have Z. Okay, so I'm just replacing now. So my Z is now the same thing here. I have 1 plus 2i, all right, minus 1 over, all right, again 1 plus 2i, like that. So that's my Z. Okay, so now what should I do? In fact, I'm not even supposed to worry about this. So what I'll do is I'll actually now look at the common denominator. But before that, I can still do something here. I also conjugate so that I can have something proper here, all right? Because I can't really add these ones properly. It will give me a big number. So let me just simplify here before I find the common denominator. So what I'll do is I'll get this inverse, all right? So I'll work with the inverse now. All right. So I want to do with this party so that I can simplify it as well. All right. So I want to simplify that one as well. So how do I simplify then? Okay. So simplifying this one now, it will be, okay. Simplifying this one, it will be, okay, simplifying this one, which is here 1 over, I want to just to simplify this so that I can subtract it properly. So I'll have 1 over, all right, 1 plus 2i, all right. So now I said now I will conjugate this one again by saying find its conjugate. I will say 1 minus 2i, all right? Then over 1 minus 2i, like that. So this will be, okay, this time that this will be just the same thing, 1 minus 2i. Okay, over here is the difference of 2 squared, so it's better I write it squared here, then minus again 2i squared there, all right? So that will be 1 minus 2i, all right? Then over, this is 1 squared is 1, then minus, remember this I which is inside, once it's squared is giving what? Negative, so that will be positive. Then the 4 squared, 2 squared, that will give me 4, all right? So this will be 1 minus 2i, all right? Down there is 5, so I'll say 5 and also 5. Okay, so that is it. So this is now my z, my 1 over z, all right? So this is my 1 over z there. So I'll replace to say 1 plus 2i, then minus 1 over something. But we have solved this one, we have simplified. So I'll just bring this value here, which is here, all right? So that will be now, open bracket, like that. So we put now 1 over 5, all right, minus 2i over 5 as well. Okay, so that is it. That is it about it. So what I'll do then is I'll just simplify now this expression. All right. So I'll say I can now group the right terms, right? So I have 1 plus 2i, all right? Then this and that will be positive there inside. So I'm just bringing this one. This and that will be negative. This one, which is the independent number, this negative here. So here it will be, this time that will be positive. The one I want to bring in because I want what? To group the right terms. So 1 over 5. Okay, then this one is negative. So I'll put it here. Negative 1 over 5. Okay, plus I want to add it with this one. Okay, hope that is not it. So you just multiply this negative throughout, then you group the right. This is what I've done. So now adding them now. So I have here what is common between 5 and, so here for the real part, okay, for the real part I have 5 as a so here I have common denominator 5, so I'll put it here, it's 1 by the way. Yeah, so even here it's 1. So the common denominator, the highest common denominator is what? Is 5. So for the real number part, so I'll say 5. Okay, then I have, there is negative, then plus, then that will be 5, right? Then here it's what? 5. So again here we'll say plus, all right, that will be 5. Okay, then there 5 into that, 5 into 1, that is 5. 5 times that is 10i, right? Then we have plus 2i, like that. So this is now on top, there is giving what? 4 over 5. Then plus, there it's 12i over 5. So this is in the form of what? A over b. I mean, this is the form that we have calculated. So this is how you find. So this is the answer. Okay. So let's go to the next question. Okay, so this question is telling us to shade, all right? So for this type of questions, you need to be very careful. So how do we do? First, you start with the universal. So when you look at this one, the lowest number in terms of negative is -5, and the highest in terms of positive is 8. So that would be our universal, all right? So I'll say this is my range. So here I'll say 8, then here it's -5. I have how many sets? There are 3. So for A, when we have these brackets, it means it's open. So now I'll put here, let's say this is 0, all right? 0 is always important. Then I have the number from the negative, the highest number as negative I can have is now -2. Okay. Then again for positive, I have 8 and 1, all right? I have 1 and also 2 there. All right. So now I can bring those sets. So I can say for A, all right, for A, so A ranges from 2, all right, to, they are all open by virtue of those brackets, okay? Then this is our A. Okay, so that is our A. Okay, then we have B as well. So B ranges from 0 to 8. So 0 here, all right? Then, okay, so then it's now closed at 8. So I'll use this dot here. Then from there, then I also bring C. C is now having 5, 5 which is open, then to 1. All right, so 1 there, which it is closed, then to 5 which is open. Okay, so now we are told to say find A, all right, intersection B, all right, then intersection C. Okay, let me not in fact lash into doing that. So when you have minus C, or if I give you A minus B, this is same as A intersection B complement. So this is the intersection C complement, okay? So that's how you do it. I just want to make it, it's more like it's subtracting, guys. So we are subtracting, don't want anything from that guy. So we'll say, I'll just, this minus there, I'll write it as, I'll write it as intersection C complement like that. Okay. So that's how you can achieve this one. So by this, then we can now go there. We are finding intersection A intersection B, then intersecting with the C complement. So the C complement that, by the way, this is B, this is C. So the C complement is, so the C complement is this party. All right. So going this side, this is our C complement. Again, we have C complement this side. Okay. All right. So then we want to intersect it with A intersection B. Where is A intersection B? A intersection B start from here, right? So A intersection B is from here. So A intersection B, you can see A and B, they will intersect at this point. This is A intersection B. Now they are saying where the same A intersection B again intersect with the C complement. So the region where they will intersect, it is this region here. All right. So they will only intersect at this point. So this is where they will intersect, right? So it's only this. Now, how do we now come up with a solution? So the solution now would be, so we are saying they're intersecting at 1 and 2. So I'll write 1 and 2 there. All right. So now how do I bring now the close and the open brackets? So we can see, let me start with the 1. All right. 1 was not part of B. All right. And wasn't part of A because they were not close, these guys, you get. So they were not included. Okay. So how can we can't also include it? Then when we come to 2, 2 is now also, it's not, it wasn't part of A, by the way. It was open. It wasn't even part of B because B was open going inside. So how can it be now? It doesn't qualify in A and B. It only qualify maybe C because it starts with this one. By the way, in fact, C is also it's also what, dotted. So meaning that the C complement is not dotted because they can't start at the same point. So we also write like that. So this is the solution that they wanted. So that's how you can bring, you can write this one. So let's go to the next question. So the next question says, let f of x be equals to this, then sketch the graph of this. So this is an quadratic equation. It's a quadratic equation. How do we sketch quadratic equation? We'll say we start with first, okay, here's a Cartesian plane that I'll write. Then, okay, this is my y, this is my x. So here we just bring the point of interest. We don't really come up with a lot of coordinates. No, I mean yeah. So what I'll do here is I'll just bring this. This function is equals to x squared minus 4x minus 5, like that. So what the first thing that I need to do is to find the turning point. So how do we find the turning point? For x, value of turning point will be given by negative b over 2a. You can find also integrating, differentiating this one, it can still give you the same. So what I'll do is I'll say this is now x is equals to our b now is what? Negative 4. That will be just positive 4. Then divide by 2a. Our a is 1, just 1. Okay. So this will be x is equal to 2 into that will be 2 like that. Okay, so that is for x. So if you want to find now for y, you can say as turning points. So turning points, so you show these, all right? So turning point, we have already 2. Then we substitute this 2 into this one. So we are getting what? That will be now 2 into that will be 4. 4. Then here it will be 8, then minus 5. So when you do the calculations there, you're going to find that now it will be 9. Okay, so your value will be 9. Okay, so in fact it will be negative 9 because that one to be 1, negative 1. Negative 1 minus 8, that will be negative 9. So those are our turning points. Okay, so after finding the turning points, now we need to find the intercept. By intercept, now we just solve this quadratic equation, then we find the x-intercept. Okay, where it is crossing the x-axis, we call it x-intercept. So how do we find now those intercepts? Okay, so we are bringing this the same equation. You have now calculated where the point. So sometimes you can even look at it when it is positive charge, you see where it will face. So now what we'll do is the points that we have is I can approximate. This is 0, right? So 2 comma negative 9. So I can say this is, let's say, negative 9. Okay, then this is the point. Okay, so this is the point. So what I'll do is now this point, it will cross, by the way, it has to cross the y-axis. So when you cross the y-axis, we'll see what will come out. So before that, let's now find the x-intercept. So we are solving this quadratic equation. So minus 4x, then minus 5 is equals to 0. So you just do what? Use factorization method. So you can see here the numbers that you multiply to get negative 4, and when you add, you get, when you multiply, you get negative 5. Then when you add, that will be now 5 and negative 5 and 1, right? So say x squared, all right, minus 5x plus 1, which is just x minus 5 is equals to 0. So what is common there is x, then minus 5. Then what is common here is 1 plus, we have 1, what is common there, then x minus 5 like that, then it's equals to 0. We can see that x plus 1 is equals to 0, then x minus 5 is equals to also 0, then x is equals to 1, x is equals to 5. Okay, hope that is clear. All right, so here it's supposed to be negative because it has crossed. Then this one, it is now becoming a positive. So now those are the intercepts. So we have at 5, let's say this is 5, then this is negative 1. So this guy is passing like this. All right. So this is how the graph, just that I'm not actually, just to show those coordinates. Okay, so you like your graph will be very neat. I'm using a pen, so this is a laptop. So what I'm going to do here is I can see again it's crossing here, so I need to know this value. I need to show them. So how do I do that? Here it's x is equals to 0. So I'll just go to the equation, say x squared minus 4x minus 5, then y is equal to there. Whenever there's x put is 0, we will see. Then that is 0, then minus 5. So here it's minus 5. So that's the coordinate. So you can say minus 0, 5 at that point if you want. So that's how you can solve this question. So the other question now says, show that this function is odd, even, or neither. So we are going to show all that. Okay, so how do we show that it's neither odd or just even? So what we do, there are rules that we do. If the function is odd, all right. So if the function is odd, first let me start with even. So if the function is even, then when we set f of negative 4, it should give us the same function, all right. So it should give us the same function. So we can be moving together. So I'm inserting negative x wherever there's x there. So that would be negative x squared minus 4 open bracket negative x, all right, is equal to, no, I have minus 5 there. So I'll say minus 5 then is equal to, which give me the same function. So I'm writing the same function this side so that I can be moving together with what I'm proving. So here it will be just x squared. Then here it will be plus 4x, right? Then minus 5. Then is equals to x squared minus 4x minus 5. Is this the same? Like here you can see here is negative. Yes, negative here is positive. So this is not equal the same. So f of negative x there is not equal to the function. So hence not what? Not even. Not even. So we have disqualified it. So let's go and prove also for odd. So prove also if it's odd or, so if you are lucky, you can just do one thing, then you, if you are lucky, you find that it will come out, it will come out exactly the way you have started it. So then you end, it can't go anywhere. So again, what I'll do is, if it's now odd, so I've proved for even. So now if it's odd, all right. So if it's odd, f of negative x should be equal to negative f of x, all right. So we'll be moving together now. Let's do it. So we are saying we are inserting now, wherever there's x, we're inserting negative x squared minus 4 open bracket, again negative x, then minus 5, then is equals to negative open bracket, the same function I'm just multiplying with a negative there. Okay, so this will give me, this is now x squared minus, that will be 4x, all right, minus 5, then is equals to, this is negative x squared, then plus 4x, then plus 5. Is this the same? You can see here x squared is negative. Yes, negative here, there is positive. So this is not equal to that. So we can say f of negative x is not equal to negative f of x. All right. So this is not odd as well. So we'll say, so you quote, by the way, when you're writing, to say if odd, then you bring this condition. So now that it's not qualifying for both even and the odd. So we'll say the function is neither odd nor even, right? So it's neither. So the function is neither even nor odd. So disqualified. So you like that statement, by the way. Let me not waste my time. So that is it. So let's go to find the values for which f of x is what? Is find the values for which of f of x is less than 0. So here is to need us to use table values, or we just use signs of values. So we are testing using signs. Okay, that's the only way. You can't predict using just the way it is there by nature. All right. So what you do is, this is what we do. So pay attention. Pay attention to what I'll be doing now. All right. So very important, like to get familiar on how to test the table values. I mean, sign graph. So you are testing signs that will be giving you positive, because the only thing that will be now greater than 0 is something which is positive. So we'll look at where the graph will be giving us, I mean the signs will be giving us positive. So what we do here is, okay, so what we do here is, I'll say what you do is you solve this equation, all right? So I'll solve this equation to say x, all right, squared minus 4x minus 5 is equal to 0. So how do I solve? We solve this one as x plus 1, all right? If you remember, after factorizing, you can also do it. So that would be negative. It's negative, I remember. Okay, so that would be just minus 5 like that. Okay, so since is equals to 0, by the way, or we are saying, let me write this, is greater than 0. So we want to test where it is greater than 0, right? So the values now, if we are to solve this one, we say x is equal to negative 1, then x is equals to 5. So now I'll make a graph like this. So I'm just interested on the signs, all right? So this is now, here it's -1 because I can see on the left that will be my negative number. Then they are like that, okay? So what I'll do here is I'll write this as follow. All right, I'll write the boundary there. All right, so I'll write, then I'll have my overall as well. So I'm saying, in fact, I'm not supposed, this is date anyway. Let me write it like this. So here I'll have x minus 5. Okay, then x plus 1 there. Okay, let me lab this on top there. Okay, so what I'm going to do here is I'll say I have, so here we said it's 5, right? So here it's 5, there it's 1. Okay, so how do we do this one then? We have numbers that are, it's negative there. We have numbers that are just less than -1, and also numbers that are greater than -1. And again, we have numbers that are less than 5, and again, we have numbers that are greater than 5. So we'll test in all those angles. So we'll be using just signs, okay? So I'll get here the way it is here, all right? I'll be using this one to test. So I'll have x minus 1 like that. Then I have x minus plus, this is -5, then this is plus 1 like that. Okay, this is what I'll be doing. Then what I'll be doing here is I'll get the number. I'll see I want to see the sign that will come here. All right, so here we'll have the overall sign. Okay, so I'm getting the number which is this side, -1. I can test -2 for this one. All right, if I put -2 for this one, then that will give me what? -2, all right? Then -5 if I put -2 there. Then you see this side, for this one, it will give me a negative. So I'll put a negative because when you add this one, they'll give you a negative, right? So that's how you test this one. Again, the same one, I can test it using now here, the numbers that are in between. I can put 0 if I want, you will see. If I want, I can put 0 here because it's in between this. So I'll put 0 there. So I'll put 0 there where there is x. So I'll put 0 minus 5. You see, the overall charge, it's negative. So I'll put a negative there. Okay. Then again, if I want again the number that is greater than 5, I can put 6 there. All right. So if I put 6, it will be 6 minus 5 here. Then that will give me a positive number because it will be 1, which is positive. So I'm done with what? I'm done with the I'm done with this first equation. So I'm coming to this one now, x plus 1. So I'm testing numbers that are this side, which the numbers that are less than -1, all right? This side, so I can have -2. So if I put -2 there plus 1, I'll get a negative, right? So I'm getting a negative number. So again, if I put again another number, which is now at least greater than -1, what would be that number? I can test 0 as well. I like 0 because it's the one which is between here, which will separate the 5 and what. So that will be now 0 plus 1. So the overall charge, it will be positive there. All right. So that will be positive. Then what about this side? Let me put the number that is greater than 6 here. So I'm putting, let me say the same 6. I mean, that is greater than 5, the same 6. Then that will be 1 plus that. That will be 7. Right? It's giving positive. Okay. So now the overall, now we are multiplying, right? We multiply now. This time that will give positive. Then let me allow me to. So when you multiply now, you want to get the overall charge. All right. So negative times negative, that will be plus. All right. Then again, negative times negative, that will be, I mean, negative times positive, that will be negative. Then positive times positive, that will be positive. So we can see this number will be, this function will be greater than, the positive are the greater than, by the way. So it will be greater than going this side and also going this side. Okay. So now how do you present our solution? Our solution now set would be, so our answer would be, I'll put this side, we are going into infinity if we are to go this side, right? So I'll have negative infinity. All right. So I'll have negative infinite. Okay, we don't close the infinite because it is such a huge number. Then I'll put again the same this one. We can't close it because if you close it, we can try also. If we close it, we'll see what will happen. All right. So I want to see if I will include um this one as well. Can I see? So if I'm including this one, it will be like this. We'll see the function if it will still give us 0. I mean greater than. So I will say x squared minus 4x minus 5. Then will it give us greater than 0? Okay. So what we do here is I'll test the same negative 1. So here negative 1, there it will be 1. Then there it will be plus 4. Then minus 5. Will it be equal to 0? Then this minus that, that will be um that will be 4. All right, then that will be negative 4, which is less than 0. So that will be 0 less than 0. Is this true? Can we have 0 greater than 0? No, it is supposed to be 0 equal to 0. So this is false. So we are not including this one. So I'll just write. Okay, so I include this one. All right, then I unionize it with again the same 5. We'll try also 5 whether 5 will include 5 or not in the solution set. All right. Can we try 5 as well? So if I try 5 there, that would be 25, right? Then minus, that would be 20, then minus 5, 0. Okay, then this minus that, that would be negative 25 again. Negative 25, this will be again 0, greater than 0. Is this true? This is not true. 0 can't be less than 0. 0 should be equal to 0. So also, we are not including 5 as well. So we'll write 5. So we'll just go to the positive infinity. So these are the solution set that we are supposed to write. Okay, this is so you should just master how to do this one. You can be given a quadratic to test again using the same scenario. So it's important that you have mastered this one. It is very simple. Hope I've explained. Hope I've made myself clear. Then let's go to the next question. Okay, so the question is say simplify the following as much as possible as you can. So we have we have the first one, we have A union B, all right? Then intersection A union B complement, like that. So what we do, we actually going to we're going to simplify things here by saying we can see that A union is common in both. So I'll get A union, okay, and factorize A union. Then I'll remain here. A union here is B. Then this one is the one which will be my boundary. Then again, A union there, I'll remain with it, B complement. Okay. So A union. So what is like we are intersecting B. Let's say I have B as a set. Then again, I have an empty set, all right? An empty set. Like it's just an empty, all right? So I'm intersecting with an empty set. All right. It's just empty. Okay. Then I have B with numbers there. Then what do I get if I intersect A and B? Like there's nothing there which will intersect between A and D. I mean we have the line B, all right? Let's say I have B. Okay. This is the line B. Okay, this is the line B. Then here going this side is the B complement, right? So how can I intersect this one with this one? They don't intersect. Even this one and this one, they don't intersect. So I'll just that it's an empty set as well. All right. So this is an empty set. So now uniting something with an empty set, it's more like 0 plus A. That would be just A. All right. So that's how you do this one. Okay. So let's go to another one. Okay. We solve also this one. Okay, so how do we do this one? So we have brackets there as A complement union, all right, open bracket A, then intersection B, then complement there, then complement that. So you distribute first this complement. You start like you respect this bracket type of brackets, then you distribute this complement there. All right. So when you distribute this complement here, it will be the moment the complement crosses union or intersection, that thing will change from union to intersection. If intersection, then to union. So this complement, you can see it to multiply there, to come there. So that will be now a complement times complement is more like negative times negative. That will give you positive. So it cancels. Then it has crossed this guy. So this will be intersection. Then open bracket. Then we have a intersection b. Then again, this time that is again a complement, so it will cancel. All right. So from there, then what you're going to do here is I can distribute this one inside. I will see what will happen. So I'll say a intersection again a. All right. Okay. Then there's an intersecting there. So I'll say this intersection again, the same a intersection times this b. So that will be a intersection b. Hope this is clear. I'm just distributing there. Okay, this one as a set, and also this one is a set. This one is the one which is separate. So a intersection a is still right. So what I'm going to do here is I'll say a intersection a is still a. Okay, then intersection a be like that. So this is just a. They will intersect at point A. So now we learned about associative distribution. So we're going just to associate these brackets. We'll bring them here. It's just the same. It's more like I have A is equals to 2, then B is equals to what? 3. So if I say A in times, intersection is more like times, again A times B, okay? This will be the same thing. Even if I do this, I bring these brackets here, or I bring these brackets here. So what I'll do, I'll do this, A intersection A, okay, then intersection B. It's still the same product. Okay, so now A intersection A is A, all right, then intersection B like that. So this will be our final answer. Okay, so that is it about this one. Let's go to the next page. So we are given this function to say x, given root 2 that is irrational. Prove that 1 over root 2 plus 1 is also irrational. So we prove this one by contradiction. So you quote that to say we prove by contradiction. Suppose you want to contradict something, then you see what to come out at the end. So suppose this one we prove by contradiction. So don't forget to write that statement to say we prove by contradiction. If you prove by contradiction, then suppose this root, okay, this one here is irrational. So we'll say suppose I won't be writing those statements. So I'll say suppose root 2 plus 1 is rational, right? Because we are contradicting to say it's equal to rational. So we equate it to the form of a over b, and b is not equal to 0. Okay, so this a and b are just members of integers. Okay, so what do we do then? We can now cross multiply, right? So we can now cross multiply by saying here it will be b times 1, that will be b is equal to, we have a root 2, then plus a there. Okay, because a times that, a there. Okay, just like that. Then from here, what I'm going to do here is I'll make this one. So I'll group the right terms by saying b minus a is equal to a root 2. So I'll divide throughout by a, because they said root 2 is irrational. So I've that got to make root 2 as my subject of the formula. So this will be b minus a over a. Okay, this goes, then this is the same. So we can see that now root 2 they said is irrational, and this form is what we call rational. Okay, so on the left we have irrational, and on the right, these are just numbers by the way, a and b, so they are making it a rational. So this makes the contradiction to our area assumption that is irrational. We can't have, they said this root 2 is irrational, and this form is this is irrational, this is irrational, then this is rational. So we can't have a situation whereby irrational, all right, is equal to rational. So this contradict our assumption. Okay, this is contradiction, okay, to our area assumption that is equal to rational. So this is not, so we have proved that it is irrational. All right, so That's how you do. You just make a statement. The statement is very important. The statement that I'm from quoting, I said, all right, I said, on the left, okay, we have irrational, right? Then a and b are just integers, which makes what? Rational. So we can't have a situation where we can't have irrational be equal to rational. That is not mathematically correct. So you leave it like that. So you explain the statement here. It was very cardinal. So now we have again the same scenario that we had at first. So we'll see also how we can prove it. All right. We'll see how we'll prove it as well. Okay. So let's go. So you start with the first, you write the universe, all right? Okay. So you look at the lowest number in terms of negative. So I can see the highest number, which is the lowest, is now -5. So since I was given universal, by the way, it's there. So it's different from the first case. Then again here I have 5. They are all crossed, right? Okay. Okay. These are just. So what I'll do here is for A, I have negative. So I'll put 0 if I told the 0. Yes, 0 there is there for B. So for A, okay, and also I have C. So in terms of negative, the other number that I can have is -3, okay, and also -2. So -3, -2. I don't have any other negative. So I'll go to positive. Now I have 1. Then I have another. Which positive again do I have? I have 2 again. Is there another positive? No, I don't have. So now I can start with A is -2 to 1. So with A is -2 to 1. So that is my A. Then my B is 0. So by the way, 1 is closed for A. Then my B is 0 is closed. Okay. Then 5 is also closed. Okay, so this is my B. Then for C, I have -3 to 2. So -3 there is not closed. Then also here is not closed. See. So how do I now solve this one? Where do they intersect? Anyway, the question says find, all right? So we are finding A union, open bracket, B complement, intersection C. Okay, this is as good as me writing A union, open bracket, C intersection B complement, which is subtraction, I said. Okay, so we are uniting. For here it's just addition, so let's concentrate here. Okay, so where is B complement? B complement is this side, right? So B complement is this side. Okay, and also this side. So now we are intersecting the same B complement with C. So B complement intersect with C at this point, right? Yeah. So after intersecting with B complement, then I'm adding now this thing that I have here with A. Okay. So the B complement here is saying I have 0 there, all right, and A. So we are adding with A. We don't care, all right. We don't care that even if A enters into B, but what we need is just the addition, all right. Okay. So and A for 1 is closed in A. So that one should be included as well. So what I will do is I'll have -3 there. Okay. This is -3. So our answer now would be, we have -3 there. Okay. Then again we're supposed to end here where there's 0, but we are told to say also A, add A, unite with A. So A is also united. So I'll put also 1. This is our last point. So see, in A, 1 is included. So we'll include 1 as well. Then for C, in the B complement, and C intersection, it's not found in C as included. So it's only included, in fact, even in B, because it starts at, let's say 3 point something going this side. So this here, this 3 won't be, this 3 here, it is not part of 1 is disqualified here, all right, and also it's not part of b. B is shaded, then this one is not shaded, so I'll write it like that. So this is our solution set. Okay, so that is it about this one. Let's go to the next question. So be very fast for this one. It involves a lot. So for you to solve this one, so let me give you some trick. So when you have a function, all right, we have a function in the modulus form like that. Let's say it's negative, not really a negative there. Okay, so when we have a function like that, so if that function, let's say a modulus of negative x plus 2, okay. So if you see that it's negative here, just know that the function is going down, all right? It's going down. Then if it's positive where there's x there, the function is going up. Simple. Then if there's an independent number here, let's say plus 2, then that is the horizontal shift. So it will go on top twice like that. Then you come if it was possible like that. So those are the just trick that you'll be using, and I'll explain them later. So now we sketch on the same axis and this one. So we'll sketch this one and this one. So just the same. So what you do first, I'll get this one of f of x is equals to root of x 3x plus 1, right? So what I'll do here is you solve this one the way it is. So have 3x plus 1, then it's equals to 0. So this is x is equals to negative 1 over 3. Okay. So that is it for this function. And also I'll come to this one as well. So let me just write the graph. Okay. So this is 0. Then what I'll do is it's starting at negative 1 over x. So it's 0 point something. So what I'll do, I'll just imagine to say it's here. All right. So this is my negative 1 over 3. Okay, this is where it's supposed to start. So you bring this one, the same equation here. You can test now table of values. By the way, this function here, it doesn't need to touch what is going to the positive by virtue of this x being positive. It's going to the positive, it doesn't want the negative. That's the reason, that's the meaning there. So what I'll do here, I'll say, um, um, I'm going to come with a table of values, eh? So these are enough. So I'll say x here, y. So it's an expression, okay? So just say y is equals to 3x plus 1. There's no independent number here. So what you do here is I'll write table of values. So I can put 0 and 1. So if I put 0 there, I'll get 1. If I put 1 there, I'll get 4, right? So I'll have 0, 0, 0, 4, 0, 1 there. Then 0, we have again 1, I have 0, 1 there. Then again, I have 1, 4 somewhere there. Okay. So then what about this side? It's supposed to turn like this. So this side again, I can test here. I was supposed to test the negative there. Let me just do this. Then let me test some negative as well. Let me just put negative 1, then negative 2. So if I put negative 1 there, that will be negative 2 as my answer, right? Okay, if I put again negative 2 there, that will be negative 6, which is negative 5. Okay, so negative 1, 2. So here it was 0 point something, meaning that negative 1 is somewhere here. All right, then negative 2 is somewhere there. All right, then again I have again negative 2. All right, so negative 2 there, negative 2, then negative 5. It's not supposed to give me a negative. Okay, it's not supposed to give me a negative. I don't know what I've done with my coordinates. It's not supposed to give me a negative. Okay, so what you do is after just doing this, so I'll plot the first one for the positive. Then you can see that it also do this. So that's how the equation will come about. So you plot on the right side, then this one will be just a reflection. Don't even bother yourself. Okay, so this is the equation for f of x. Okay, then what about for the other friend? We are told to also do this one. So for the friend also, h of x is equal to, so we have 2 minus x, then minus 1, like that. So this is negative, right? So the graph will now go down, but what you do is get what is inside there, solve. So this is x minus is equals to 0, then x is equals to 2, right? It will be a negative, then x is equals to 2. So you go where x is equals to 2. X is equals to 2 is at this point. Let's say S2. Now that there's an like horizontal shift of -1. So you go one step, -1, you go to a -1. -1 is somewhere. So here our point now, initial point will be like this. Now by virtue of this x being a negative, it will face down there. Okay, just know that the graph will face like that. Don't even bother yourself. The graph will face like that, even without plotting the coordinates, because it will look dead when you plot the coordinate. So the graph will look like that. After looking like that, c is -1, by the way. So after looking at that, then we need to do something here. Okay, so we need to find where now it is intersecting here. Okay, so it's like, so we'll put x is equal to 0 there and that. So say hx, or just y, is equal to, open bracket, then 2, then we are saying we are putting 0 there, all right, then minus 1. So that will be what, there inside there, it will be 2, all right, it will be 2 minus, that is 0. Okay, so that is 0. So absolutely the inside there we have -0 there, all right, then wait, suppose there was a negative there, wait, just wait. So we want to see how it will cross. All right, it need to cross this guy at a certain point. So put in this general equation, we'll put, okay, so we are going to put in this general equation, which is h x of that, then we have 2 there, right, minus, okay, then x there, okay, then minus 1, like that. So we need to see where it is crossing here, and we know that this is our y-axis, this is our x-axis, right? So that is it. So what are we going to do then? So we'll say we are going to put the value there. We'll substitute the value so that we find this value here. All right. So we'll say this is my y. Want to see the value of y. Okay. Then since this is my y, then I'll put 2 there. Okay. Then minus, I'm putting in value there. X is 0 there, right? All right. So x is 0 there. Okay. Since x is 0 there, then what I'm going to do is I'll say this, then minus 1. So this will be, my x there is 2, all right, then like that, then minus that. Okay, then what I'm going to do here is I'll substitute now. I'll say my y there is giving me 1. I don't know, it's not supposed to give me 1. Something wrong here. So let me do this. Okay, so just wait for a moment. Okay, so let me just show some coordinate here. We said this is the this is negative 2 comma -1, right? So we need to show this coordinate, and also here if we put 0, let's try for this one first. Here we'll see what will come out, because we need to see to show the intersect. So if I put 0 there, all right, if I put 0 in this function, then it will be 1, right? If I put 0 there, then it will be 1. But if I put again here is 2, if I put 0 there, it will be just 2. So it's not giving the any diff. Okay, there must some error there. There must be some error. Okay, need to be some error there. But it's supposed to give a negative there. I don't know why it's refusing. Okay. So let me try to put what number can I put? What number can I put? If I try 5, let me just try to put 5 there. So y is equal to, open bracket, 2 minus 5. I just want to try something. Then this will be y. That will be negative 3. Okay, I've seen. Then minus 1. So this is the value of x. Okay, so you concentrate with what is just there inside, all right? Concentrate with what is inside there, all right? So concentrate with what is inside there. So what you are going to do here is we get this thing here, okay? So you get what is there inside there, then you substitute the value of x. That will give you 2. It's supposed to be negative. I don't know what happened to this question, but I'm finding an error there in my solving. So that's how you can actually solve these things fast. Otherwise, all right. So we send the correct question solution after we solve it properly. Okay, so that is it. Master the way we have just approached. This was just a fast forward. Remember, it's a revision, so you need to know what is wrong with this one. So let's go to another question. We are done solving the two graphs. This is h of x. This is h of x. This one you can see there. So the key word is to know these things, the way they will affect the graph, and also the shift, the horizontal shift. All right. Okay. So now be very fast to solve this one. We are told to say let f of x be equal to this one. Then g of x is equal to this one. Find the domain and the range. How do we find the domain? Very important thing. So for this case, we don't want a domain or the range of values to give us negative down there when you substitute for x. So what you do is you get this one, okay, 3x minus 5. Let not be equal to 0, so that you don't want something which will be equal to 0. So this will be 3x, then is not equal to 5. Then you divide throughout by 3. So x will not be equal to what? 5 over 3. So x will be all those numbers but not equal to. So we'll say the domain now, all right? The domain will be, okay, the domain will be x is not equal to 5 over 3. Then x is a member of all your numbers, okay? All the numbers on the number line. So that's how you find the domain for this one. Okay, find the domain of f of x. So this was supposed to be f of x. Then find the inverse function of f of x. So how do we find the inverse? So it's very simple as well. You can use the one secondary level method. Okay, so what you are going to do here is to find the inverse of this one. So you you equate this one equal to y just like that. So we have 25 over 3x minus 2. By the way, I've made a mistake. This was supposed to, I thought it's 5, this 2 here. It's not, so equate to not equal to 2. I'm sure you are getting now my point. So you equate this one not equal to, then the domain will be all those numbers, but this one not equal to that. So what we do here to find the inverse, you say, you make x the subject of the formula. So that will be y. So 3xy when you multiply, then minus 5y is equal to 25. So now we make x the subject of the formula. So it will be 3xy, then is equals to 25 minus 5y. You know, I'm repeating the same thing instead of writing 2 here. Okay. So this is 2y. Okay, so it's 3x, y is equals to 25 minus 2y. Then we divide throughout by 3y. Okay, so our y is equal to 25 minus 2y over, you see the mistake that I'm making? Okay, so I'll say 2y there. So I'm making a very big mistake, but you can see. So what you do here, this is the inverse. So now you just say therefore, okay, the inverse of f of x is equal to, you substitute wherever there is z, so 25, then plus 5x, which is 2x I've been repeating. So this is 2x over, all right? This is again, I was supposed to divide 3. Have you seen the mistake that I'm making? So I was supposed to divide by 3y, which is now 3x. You substitute like that. So this will be 25 plus 2x over 3x like that. So so this is how you do it, all right? So I've really made a big mistake. Hope I've not confused someone here. All right. We are saying, let me do it first. We are saying we have y is equal to 25, right? Over 3x minus 2. So we make this one as the subject. So you multiply, okay? We have 25 there is equal to 3xy, all right, minus 2y. Okay, then we want to make x the subject. So this will be 3xy is equal to 25, all right, plus 2y. So then you divide throughout by 3y, okay? Then even here 3y. So our x now is equal to 25 plus 2y over 3y. So you substitute as the value of x, then our final answer will be, I'll just bring this 2 here. So I'll say 2, then you attach x wherever there's y, then plus 2, 5 over 3x. So this is our inverse. Then to solve this equation now, this is very simple that we can't even fail, all of us here. So what we'll do here is, okay, so what we do here is, we said this is fog, right? We are substituting g of x in the f of x. That's the mean. Then we equate to that. So I'm bringing this function f of x, all right? Then you can see here, I can write it like this. So what I'll do is I'll write g there, then f of x. So meaning that in the f of x, I'm putting g of x, all right? So that is now my f of x. So my f of x is 25 over, wherever there's x, I'm putting g of x. So I'll have 3 open bracket, then x plus 1, then minus 2 there. Then they are saying is equal to 2 over x minus 1. So here I'll have 25 over, down there is 3x, now multiplying, then plus 3, then minus 2 there. Then they are saying this is equal to 2 over x minus 1. Okay, here I can solve here. So I have 25 over 3x, then plus 1 is equal to 2 over x minus 1. Okay, so that times that, I'm crossing multiply. So I'll have this time that will be 25 x minus 25. Okay, then is equal to this times that, 2 times that will be 6x, then plus 2. Okay, grouping the right term. So this will be 25x minus 6x. Okay, then is equal to 2 plus 25, like that. This one go there. So here minus that, what is the 25? What is 25 minus 6? Okay, 25x minus 6. What is 25x minus 6? So that will be 19, right? Okay, so that will be 19 19x then is equal to, this is equal to what? There must be a negative there. All right, it's showing a positive. So what I will do here, I'll say, I don't know if I've made a mistake, but it's showing that here it's giving me 27, of which I don't think is the case. So then you divide throughout by 19. Then we'll be able to solve the value, all right? 25 over 19, if I'm not mistaken. So this is how you should solve the equation. All right, so we are done with that one. So the other question says, we are told now to, if alpha and beta are roots of the equation 2x squared minus 3x minus 2 plus 2 is equals to 0, find the quadratic. So what we need to know is that, first, alpha plus beta is given by negative b over a. Then again, we have alpha times beta, which will give us c over a. So let's find these ones. So we have here, all right? So here we have negative b there in the equation. So we have negative 3, so that will be just positive 3 over a. Our a is what? 2. Okay. So our alpha beta, it will be just alpha plus beta, it will be 3 over 2. Then here we have c is what? 2. Then that one is 2 also a, so which will give us 1. Okay, so this is equal to 1. Then this is equal to 3 over 2. Okay, so that is it. So these are the values that we'll be using now. So what is remaining now is to add and also subtract what you have been given. Remember, our equation will look like x squared, right, minus open bracket alpha plus beta, all right, then x there, then plus, okay, alpha times beta, like that, then equals to, this is our equation form. So what we need to do is we'll add this one, then we can put there, and again we multiply, we can put there. So adding these two, so we have 1 over alpha beta plus 1 over alpha plus beta. How do we add these ones? Then we'll say what is common there is alpha beta, okay, open bracket alpha plus beta, just like the way they are there. Then we multiply this into that, that will be alpha plus beta, okay, plus again this into that, that will be just the alpha beta, like that. So this will be alpha times beta, we alpha plus beta, we saw it's what? 3 over 2, right? Plus alpha beta is 1, right? Over, we have again alpha beta is what? 3 over 2. Then open bracket alpha plus beta, we have 1. Okay, so here what is common here is 2, then that will be 3 plus 2, which is 5 over 2. Okay, then divide by 3 over 2. So it's more like 5 divided by 2 divided by 3 over 2. All right, so they will swap, this and this will cancel if they swap like that. This will be like that, so I know 2 over 3, this goes, then that will be 5 over 3. Okay, so now this is our sum. Okay, so we can put there, so we say x squared minus open bracket, this is our 5 over 3, then x there we attach, then plus, we are remaining with the product type now. So how do we get the product now? So we are multiplying these two guys. So multiplying these two guys, we are getting, so multiplying these two guys, we are saying we multiply this time that. Okay, right? So multiplying these two guys, we are getting this time that is 1 on top there. Okay, then we have alpha beta, right? Then being multiplied with alpha plus beta, like that, right? Okay, so remember we have 1 there on top, then alpha beta is 1, then the addition there, we found that it was 3 over 5 over 2. So this will be 1 over 3 over 2, which will be 1 divided by 3 over 2, which will be 2 over 3. Okay, so I'll come put there 2 over 3, then it's equals to 0. So this is our equation, that this is the equation that they wanted. So you can also practice on how to prove, to show that, or just master the squared and also the cubic ones. All right, you can master those two identity. how to drive it. So our final equation now to be x squared minus 5 over 3x plus there 2 over 3 is equals to 0. All right. So I can cancel this by multiplying throughout by 3 so that this 3 can go. So how 3x squared minus 5x then plus 2 is equals to 0. Okay. So that when again I divide throughout, okay, it will give me the same stuff. Okay. So that is it. So that's where equation will end. It will end here. By the way, if I multiply this time that will give me 6, right? Yeah. So this time that, then 3 will go, then again 3 will go. Okay, it will remain just like this. Okay, so that is it about this one. So now the other question, which is the last question to say maybe. So we have, given that x minus k is a factor of this one, then it's a factor, all right? Then k is a member of real numbers. Find the possible value of k. So if it's a factor, then it should give us 0. So what we are going to do is, we'll say it should give us 0 if it's a factor. So we'll say kx cubed, all right, minus 3x squared minus 5kx minus 9 there. Okay, so what I'll do is, I'll say I'll substitute. So I'll solve this one, okay? What I'm going to do here is, I'll say I'll solve the value of k here. So I have x minus k. So solving is equals to, let's say, 0. So x is equals to k. So wherever there is k, okay? I mean, whenever there's x, I'll put k, okay? So that I can have one thing. So I'll say 0 is equal to k. So wherever, again, there is k cubed, then minus 3, again k squared minus 5, again k, open bracket, again k minus 9, like that. Okay, 0 is equals to, what I'm going to do here, I'll say this is k to the power 4 minus 3k to the power 2, then minus, okay, k squared again. So this will be 5k squared minus 9. So this is 0 is equals to k squared, no, k to the power 4. Then here it's minus 8k to the power 2 minus 9. So how can I solve this one? I can say even the same, let's say let any letter, I can say p. P is equals to k squared, okay? So if I put like that, then here it will be k squared. So it's more like I'll have k squared, open bracket, 2 there, minus 8, then k squared minus 9. Remember I said p is equals to k, okay? So I'll put p there, then p squared, I mean k squared is equals to that will be 2 minus 8, again k squared is p, then minus 9. So I'm solving this one quadratically. So I'll say p squared minus 8p minus 9. How do I solve this one now? How am I solving it quadratically? So what I'll do here, I'll say I'll factor out, okay? So the numbers that I'll multiply to get negative 9, then you add, get that. So that will be 2p. Then I'll use negative 9p plus p to get this negative. Then again, when you multiply, they still give you this. Then it's equals to 0. So what I'm going to do here, I'll say p there, all right? P there is equals to what? So you factor out what is common there is p. Then p minus that will be 9, right? Open bracket. Then again, what is common there is plus 1. Open bracket, we have p minus 9. Then it's equals to 0. So we can say p plus 1. Open bracket. Again, we have p minus 9 is equals to 0. So meaning that p is equals to negative 1. Again, p is equals to 9. So you can see now that p is equals to 9. This one will be discarded, is that is having a negative. We are saying p, it was equal to k squared, right? So now putting negative there, it won't make sense. But if you put 9 there, is equals to k squared. We can find now root of this. So k will be equal to plus 3, I mean positive or minus 3, which is accepted one, is what? Plus 3 like that. So that is the acceptable value or the possible value that they wanted for k. The negative one, just avoid it. So that's how you can solve this one. All right, let's go to the last question. So I want to prove that this one is real. How do we prove that this function or this equation is real? So when something is real, let's now go back to what we have done in the first page. On the first page, we said we are going to conjugate this one so that we want to make sure that these complexes are cancelled, these imaginaries are cancelled. Okay, how do we do that? We'll say what I'm going to do here, I'll say I'll group the right terms. I'll find what is common there is 3 minus 1 like that, again 3 plus 1 like that, plus I like that. Okay, then on top there is still the same. I'm multiplying, this one is multiplying that one and this one like that. Okay, so I'm going to do this. I'll say 1 plus 2I. All right, it's multiplying with this one, so it's multiplying with 3 plus I. Okay, then plus, then again this one 3 minus I is multiplying with this one on top there. So that will be open bracket 1 minus 2I. Okay. So this is the thing. So what I'm going to do here is, here it's difference of 2 squared down there. So this is just the difference of 2 squared. So I'll say 3 squared minus I squared like that. Then what I'm going to do here is I'll multiply now. This time that will be just 3. Then 1 times again that will be just 1I. Okay, the complex. Then again I'm done with this one, then I come to this one. This time that is 6I. Okay, again this time that will be, now I times I is negative, so it will be just negative 2. Okay, then plus, this time that is 3, then this time that 3 times that will be negative 6I, then negative times negative, that will be negative I. Then again, negative times that will be positive. Again, positive times that will still give us a negative, because the negative will come from the result of multiplying this one. Then there's also this one which was cancelled, so it will be just a negative 1. So down there I have this is squared is what? 9. Then that will be minus, which will be just plus 1. Right? Then on top there I have this plus the constant numbers I have, negative times that. So I'll say 3 minus 2 plus 3 minus 1, this and this and this. Okay. Then the imaginary ones I have plus 1I plus 6I plus 3I. Okay. Minus 6I. All right. So we are saying this plus this. This is the one. Then 6 plus, we have 2 6's. Then that is 6. Let me do it for imaginaries. Okay, so I've started with this one, then I'm coming to which one? Plus 6. Okay, I'm coming again to negative 6. Then I'm coming to I there. Okay, so we can see now this plus this will be now 6. 6 minus 2, that will be 4, right? So that will be 4. Then we have now 4 minus 1. Okay, so I said this plus this is 6. Okay, then that one minus that, so that's 6 minus that. So I'll say, so 3 minus 3, it is here it's 1, then plus 3. So that would be just 3, right? That would be just 3. So it's not supposed to give me 3. There's a mistake there. Okay, so what I need to do here is, let me just get it from here. This 3 here, all right? This 3 there, we said this time that is 3. Then this time that it's 1i, just like that. Then 2 times 3 is 6i. Then again 2 times that is -2. So here it's correct. Then again I multiply 3 times y, 1, that is 3. Again 3 times that, that is -6y. Again this one times that, that is -y. Then this time that, I've made a mistake on the last one. This time this is supposed to be a negative, of course, but -2. Okay, so now that I have this, so I'll have this is supposed to be a -2. Okay, so I'll have negative, so here I'll have -6. This, okay, let me simplify now. So I have 3 minus 2, that will be what? That will be 1. 1 plus that is 4. 4 minus 2, that will be just 2. So here we come here, we say this one is what? 6 minus that, that is 0, right? Then this minus that, that will give us, even this and this is going, have you seen? So we are just remaining with 2. Then down there, this is 10. So meaning that this is 1/5. This is Leo, it's not imagined. It doesn't have the I thing you were saying. So it's removed. So we have proved that, we have shown that it's Leo. So this is a real number. So we have imagined number, this one, and also the constant number, which is real. So this thing is real. We have shown. Okay, so that is it about this one. Okay, this marks the end of all the questions. Make sure that you master them.